It's now time to build your Mark I STEM kit, and this is what makes MaxIQ so cool. With the X-chip design architecture, you can literally build a working spaceship in a couple of minutes. A simple one to be sure, but once that's done, you can add complexity with custom programming, more X-chip sensors, and you can even make and connect your own sensors depending on what your experiment needs. The sky is not the limit here. It is literally just the first step. Now, the Mark I SDG and STEM Kit comes with 8 of these 10-pin connectors, the signature connector of MaxIQ, and because no soldering, breadboarding, or external lab equipment is required, building a kit or swapping out X chips to run a different experiment will take just seconds. Unless you've launched the thing into space. In that case, swapping out the chips does get a bit trickier, but for rapid prototyping on the ground, it cannot be beat. A few key terms here to keep in mind as we prepare to build the kit. The first is input. Now, an input is basically a device through which energy or information enters a system. That information or data is usually taken in by a sensor of some kind. And to that end, the MaxIQ STEM kit here has 3 data input sensors. We've got a light sensor, a weather sensor, and a soil moisture sensor. Now, some chips, for example, the light and weather sensor, can be a little bit difficult to tell apart just by looking at them, but fortunately there are these icons here in the lower right corner of each chip to make it a little bit easier. The Mark I STEM kit also has one power input device, and that is the USB interface here. Now, the USB interface also lets you flash code that you have developed yourself onto the device. Generally, uploading a new program is not exactly considered to be input, but it is new information entering a system as energy. So I'll let you decide amongst yourselves if this counts as an input. Okay, next we have an output, and this is a device through which energy or information exits a system. Now, the Mark I STEM kit has 3 output devices. We've got the OLED screen here, the core processor here, and also that USB interface, which will allow you to connect the kit to your computer if you prefer to transfer data directly into a spreadsheet without using an internet connection, which you can do with this core processor. And speaking of processors, let's talk about what that is exactly. Okay, so a processor is basically a device that receives data from the inputs, refines that data according to its programming, and then delivers the result to the outputs. Now, a good thing to know if you want to get even more technical is that a processor is a type of integrated electronic circuit that performs calculations to run a computer. An integrated circuit is a set of thousands or millions of individual circuits all laid out on a semiconductor wafer so that they can work together. And there is such a wafer here in that ESP32 chip. Now, every computer is fundamentally an adding machine, and every one of those individual circuits is made up of some combination of resistors, capacitors, diodes, and transistors, all in order to perform different types of basic addition problems very, very fast, all at the same time. Oh, and by the way, this isn't just any type of processor, this is a microprocessor. Not that macro processors were ever exactly a thing. I'm sure Bjarke would be more than happy to share a little bit more about that if you're interested. Now, the core computing module in every Mark I STEM kit has been loaded with Arduino code at the factory, so it will work out of the box. But it can be overwritten with code developed in Arduino, MicroPython, Java, C, and C++. So, as we've seen, a single device can have multiple roles. But basically, to make a long story short, the processor will take data or information from these input devices, process it, naturally, and then send the results to these output devices, so long, of course, as it has power. Okay, let's build. Once you've planned or chosen the experiment to run, you'll know which chips you will need. And as you determine how best to connect them, it is good to lay them out, like in this example here. First, kind of a step 0, take any chips that you do not plan to use and put them back in the box so that they do not get lost. And if the chip came in an envelope, for example, or perhaps some bubble wrap, then you'd want to put them back in that as well, just for a little extra protection. Returning our focus to the workspace here. We want to make sure that every X-Chips icon is in the lower right-hand corner so that each chip is in the proper orientation. Just like that. And I'm going to speed this part up, so hang on to your hats. And remember, you try and handle the chips by their edges. Whoops. Now this is the side of the chip, right? So the part that's actually making the connection, you can see the 10 pins there. There's this little plastic bit that you want to make sure matches up with this little gap. Here's that OLED screen. So this is, oh, it's especially delicate, especially important to just handle by the edges there. The mechanical chip, and this just makes sure that the whole kit is sort of structurally rigid. And then you want to make sure that you apply the pressure fairly evenly as you connect the two columns. So you connect the columns and then you connect the columns. Kind of a funny way to put it, but you see what I'm going for here, right? Sort of a little squeeze in each direction to make sure that it is fully connected. And there you go. So congratulations, your Mark I STEM kit is built and ready to run its first experiment.